Let's take a look at Dr. Dan Siegel's hand-brain model, brought to you by the Center for Child Counseling.
How does your brain respond under stress? We're going to build brains today and explore that response. The more that we understand how the brain works, the better we'll understand that response as well as mitigate the effects of it. Before we explore what each region of the brain is responsible for, it's important to remember that the brain developed from the bottom up and the inside out. This same process is also followed when our brain makes sense of new information. It travels from the bottom, up and inside the brain to the outermost regions, meaning the outer and upper regions of the brain are the last to develop in life. For example, that prefrontal cortex only develops fully at the age of 25.
We're going to use our hand to create a visual of what the brain looks like and how it processes information. Your wrist is the spinal cord, which travels from the spine to the base of your skull. The base of your palm is the brainstem. The brainstem regulates the basic functions of our body, like breathing, heart rate, body temperature, and digestion. Basically, all those things that we don't need to sit around and think about in order to keep us alive. It's known as the reptilian brain, as it's the most primitive and primary function is survival and arousal. For example, if we're hungry or not, or where we are between the stages of being awake and asleep. Your thumb is the amygdala. Fold your thumb into the palm of your hand and you'll form the limbic system. The limbic system is responsible for our emotions, memories, and activating our survival response, that fight, flight, and freeze system. This is known as the mammalian brain. It works closely with the brainstem and the body to create not only our basic drives but also our emotions. More specifically, the amygdala is responsible for detecting threats to our well-being, and it sends a signal to our brain, hormones, and body to keep us safe. Is this good or is this bad is the most basic question that the limbic system addresses and responds to. Your fingers form the cerebral cortex, and the tips of your fingers are your prefrontal cortex. If you close your fingers over your thumb to form a loose fist, you've just created your brain. The cortex, which is the outer layer of our brain, is our thinking brain. It's the part that allows us to imagine, create, problem solve, as well as understand abstract concepts. The prefrontal cortex in particular helps us evaluate the situation that the amygdala signaled as a threat, and it controls our emotional response before our feelings escalate to the point where we can't control them. That prefrontal cortex is the region that only develops at the age of 25. It's responsible for our executive functioning, things like controlling short-sighted, reflective behaviors, and it allows us to do things like planning, decision-making, problem-solving, self-control, setting short-term goals for long-term outcomes. This is the area of our brain that really focuses our attention, anticipates consequences for our actions, manages our emotional reactions, and plays a huge role in our ability to put our thoughts and feelings into words.
These fold over the limbic system to create your brain. This would be the front and this the back, where that spinal cord runs down the spine. As clever as our brains and bodies are, they use a sort of standard approach to all stress. The best way to think about this is that our brains and bodies are designed for survival, and so it interprets stress as a threat to our well-being. This means that if it's a bear coming towards us in the woods or an upcoming deadline, our brain responds in the exact same way. The amygdala detects the threat and signals the brain and body to release those hormones for fight, flight, and freeze. What that does is pulls resources down to that survival part of the brain and flips the lid to switch off the unnecessary prefrontal cortex and cerebral cortex, as those resources aren't needed for survival. So now we're thinking from that survival-based reactive region, and that executive functioning that lies in that prefrontal cortex region has been temporarily turned offline. This means our executive functioning is hindered for that moment. So things like learning abilities, problem solving, planning, and decision making aren't going to be as effective as usual when our lid has flipped. So how do we get that lid back down? How do we get that prefrontal cortex back online? Well, to return that lid, we need to regulate. And this is done through the use of coping skills and social supports. By putting into practice techniques to calm down or connect with others who are safe and calming, we're providing our brains and bodies with evidence that there's no further need to feel threatened. The more we practice these techniques, especially when we're feeling regulated and our brain is fully online, the more effective they are in moments of need.